Hello, now I'm going to discuss question 3 of homework 3. So this is about the maximum likelihood estimator for the binary distribution. So the binary distribution is the simplest possible distribution model. So I'd like to use this as an example to explain some details, some subtle nuances. Let me first discuss super simple, even simpler case that where you make a lot of mistakes. So think about this simple mathematics question. Suppose that there is a quadratic function f(x), ax squared plus bx plus c, and a is positive. And then the question is you have to find the derivative. And if m is the minimizer, then you find the minimizer. So you know how to handle that, but you know how to solve it, but you have to be able to explain the flow of the solution. Right? I know that you can mechanically solve it, easily solve it, or you may already remember this answer. So then getting to the solution is not a problem at all. What I want here is you should explain that, and you should now at this point you should know what means what, whether you have a rigorous answer or not. You can write a rigorous answer or not. So I would say this way. So the correct answer goes like this. The first question, derivative, is this one, and the minimizer satisfies this. This is the first order condition. So from this you obtain this. Okay, you know, this is very simple answer. Answer is pretty simple. But now let me show you wrong answers, wrong equations, such as this one. The function f(x) is am squared bm plus c. It's wrong. M is a fixed minimizer, is a fixed number. X is a variable. X is variable. You can put different number into x, but m is just one constant number, right? And also, of course, this is of course wrong. Exactly the same thing. X is variable, but this is another fixed number, constant. So the left hand side, right hand side are not equal. So they are equal only when x equals to this. And this equality holds only when x equals to m. So equation itself can be wrong unless you have a condition. So this equals this if x equals to m, then it's right. Similarly, this is wrong because on the left hand side, this is a derivative function. It's a function of x, right? You can put different x here, using different x here, but on the right hand side, you already fixed x equals to m, right? So this is true only when x equals to m. So in general, this equality is wrong. Again, this is wrong. This is wrong because the derivative may be different from 0 depending on x. So this is true only when x equals to the minimizer, right? And finally, if you just write this way, then it is wrong. You have to say something. So for example, you have to say that the solution to this first order condition is this, something like that. So x, again, x can be a different variable, different value, but you are specifically considering this specific one. Like in this example, you may think these wrong equations are obviously wrong. I believe you understand what I wanted to say here. I will explain. You make the same mistake like this. So I will explain that later. And another question, or another digression. So suppose that you wanted to say, I wanted to tell you, if you are a genius, you don't need to work hard. For example, like if the statement may be wrong, you may not agree with that, but just as an example, just say that. So I say this to a student, if you're a genius, you don't need to study hard. But if that student told it the same statement to another friend in this way, then it is wrong. This statement is totally different from this one. I didn't mean you don't need to work hard. So the meaning of this sentence is you have to work hard, but only one case you don't need to work hard is when you are a genius. Okay? So think about this case. And now going back to the first order condition. Again, suppose that a differential function is maximized when x equals to m, right? So again, if you are genius corresponds to this. So I'm not saying this is always maximized. It is maximized at a very special case when x equals to m. And then the first one, mathematically, the first condition is this structure. If the variable x equals, in a special case, equals to the maximizer, then the derivative function will equal to m in that specific case. So the first condition is mathematically on if and then sentence. If something happened, if something is true, then something would be true. So it is a if and then structure, but many of you are just saying equals, excuse me, it should be 0. Many of you are just saying this part. I understand, you know the full first order condition, but if you just write it this way, it is wrong. This is exactly this, right? So what you have to do is you have to always put the condition for this equality to hold, right? So if you just write this way, it is wrong, as I said in the previous page. So I believe you understand why these are wrong. Then now let's go back to your answer. So like here in this question, what intentionally I made the question confusing because there are different p. For example, this p, the likelihood is a function of parameter p, but this p can take different values. Of course, the value should be between 0 and 1, but anyhow, it is a function of a variable p. So this is not a fixed number. You can think about different numbers, like 50%, 60%, 70% can be plugged into this variable. And another p, p0. p0 is a specific true value. So p0 refers to the true value of the parameter. So here, as I said, this was any value, can be any value, but this is not just any value. It is one special value that is the probability of x. And later, there is another p, which is p hat subscript n. This is your calculated p. So there is you set up a parameter p, and then there is a true value, only one specific value. That is the truth, but you don't know this. But so you wanted to calculate that using this. So calculate something to estimate the true parameter. So there are 3 different p notation. So I want you to distinguish them more carefully. And furthermore, you may wonder, these are too obvious. So A and B, question A and question B are pretty obvious. So you may think, why did I make these questions? But the reason is because without having them as questions, you cannot handle this. I'm really sorry, but some of you, I believe most of you are good enough to directly solve this out. But in the past, there were some students who did not understand how to solve this. So I wanted to have the first question like this. Just you can calculate the log likelihood and then derive this. But many students could not find the derivative. So I gave you a hint like this. Then they did not understand where this is coming from. So I explained this and this. in the same way, right? So like from the past few years, several years, I've been here for like 9 years. It's my 10th year. So then, I changed the homework to to match the students' level. But then sometimes it can be too easy. But please understand that's not your fault. Even if it's too trivial, just you can say trivial. Okay. Now let's look at your answers. If there's any comment. So most of you guys have done pretty well in A and B. So here, this student did an interesting work. Okay, I understand because maybe I believe this student thought this is obvious. Why? How to solve it? Like how to prove something's obvious. Okay, so he used a binomial distribution formula, but I have to mention that, right? So writing this has no I don't know where it's from. I know it, but in general, the proof is not complete because I cannot tell why this equality is true. So I have to say we know binomial distribution takes this form, so we can think it as a special case where n equals to 1. Also, had to mention that. So like n should be included in here to use the general binomial distribution form, right? So this should be n, otherwise it's not general enough. So did well. Again, I understand. Yes, plug x0 or 1 into this and we get but you have to write something more, right? So like when I read this answer, my feeling is that 3 lines. So if you wanted to write 3 lines, then the main part should be plugging in. So this should be the main part of this answer to spend 3 lines. But one and like a lot of so this is pretty much useless, and this is what I gave you in the question. So in the end, even though there are 3 lines, the information contained in 3 lines are nearly nothing. So please like think that way. You wanted to say something, but you don't need to write just unnecessary thing. Okay, did well. Excuse me. In here, here notation problem, x equals to 1. So this student wrote p0 times x equals to 1. This does not make much sense because x equals to 1 is an equation. It is not a variable. So when you multiply something to something, something has to be a variable, an object like constant or a variable. So I understand what it meant, what she meant. Like x wanted to say 1 here. So it should have been 1, not x equals to 1. So this is grammatically not correct. So kind of, you can think it as a literally grammar thing, right? And question C, just derivative thing, and finding unique minimizer. So let me show you. So here, this is what I said. On the left-hand side, it's a function of p. P is variable. But on the right-hand side, suddenly it becomes p0, which is a specific constant. So they don't match. The equality is not true. So as I said, like this is not correct. Like if you agree that this is not correct, this is not correct, then this equality is not correct without any more conditions. So at least you have to say something more, right? And similarly, this is wrong, and this is wrong. The left-hand side argument and right-hand side argument do not match. So same problem happen throughout the answers. And again, here, here. So this is the first order condition. Exactly this is what I wanted to say. So it starts from derivative at p. So it's a variable. Argument is p. Then suddenly it becomes p0. And suddenly becomes 0. So I don't know, there are conditions for each equality. So for example, in the first equality, this equality is true only if p equals to p0, and this equality is true only if p0 is the maximizer or minimizer. So have to say that, otherwise these two equalities are not true. But I understand what you wanted to say, but you know, again, let me compare this to this. What you wanted to say is this, but if you say it this way, it is wrong, right? Like, that's the problem of writing something. So in your dissertation, you have to be careful like this. So every line can be criticized. Did good job here, did well. Okay, nice done. And here, so first, okay, Q0, the argument is missing, but it's a minor mistake. Again, so I believe Q0 is a function of P, but suddenly it becomes P0. So like a notation not matched, and then suddenly it becomes like expectation of x, because P0 is expectation, but here what she had to say was it is, so here Q0 of P, function of P, and then it should be P, and then it should be P. And here, so when the argument equals to this specific value, then the first order condition is satisfied. So it is nice to state the condition, like in this structure, when this condition is true, then first order condition is true. So that is nice. But the notation is not correct. Similarly, same thing happens in the second order condition. Here, good job. Like, I just minor thing. So we usually write p equals to p0, not this way, because p can take multiple values, but we usually say p equals to, so we usually say x equals to m. So x can change, x can vary, but among many possible values, it is specifically equal to m. That's what we mean. And then following the sentence, like you are speaking a sentence, you have to say p equals to p0. That is a more natural writing. Here, like algebra mistake, it should be, I believe it should be negative. I don't know where the mistake was made. Because we are doing maximization, it should be negative. Okay. Again, here first order condition equals to 0 if something is happening, if p is minimizing or maximizing the function, something like that. So this equality is true only if something happens, right? Only if a certain condition is satisfied. And again here, I think he wanted to say p equals to this part. This equality is true because we already proved it, part A. Then if this is true, then something happens, but this is always true. Then always true by our definition. Then equation of satisfies. So the condition is not implied, but this equation is not always satisfied. This condition is always satisfied. Something is not matched. So I believe it should be P. Should have been P, not P0. Job. Here, I don't know. I don't remember. Like -2, algebra mistake, should be exponent of -2. Okay. Next, determine the Hessian matrix and variance matrix. let's see. It's like here again. Now another tricky part is now I specify P0. Now we are considering a specific point of P, so it is different from these guys. So above P was variable, but now I specified it, I fixed it at P0, so the notation should change. Like P0, this is correct, but this is incorrect. And we know expectation is P0, not P. So P is variable, but P0 is the correct thing. And similarly, P0 then it should be P0. Again, it should be P0. P0, the notation is not consistent. Oh, here did a good job. Again, same thing happens. P0, P0, and I don't know where this condition is coming from. I think some mistake. Here again, omega, capital letter omega, depends only on P0, so everything should be P0, 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 and then we know you can calculate this expectation using the parameter P. So in the end, this equals to P0. So something is wrong. Excuse me. This is P times, so this variance is P times 1 minus P, P0 times 1 minus P0. So you should be able to calculate this guy. And some algebra mistake. This algebra is not correct. So this is not true. Variance x is not expectation x squared, because expectation of x is not 0. So this equality is wrong. And great job. Good job. Let me see. Again, here P0, I specified it as P0, but suddenly it got correct. So this is wrong, but the next line is correct. I believe there was some algebra mistake here. I don't know how this is derived, so I'm not certain. There is somewhere there should have been a mistake. There must have been a mistake. Okay. The next question, simple. G, find the closed form solution. Let's see. Here, I don't understand what the student wants you to say. So NPN, QN, maybe QN should have been Q hat N, I guess. But here, like notation error, it is not P0, should be P. And again, here equals to 0. Maybe I guess like should be outside the parenthesis. Okay. Mismatch, right? Notation is mismatch. So it's general P, argument variable P, and this is a specific value that you calculate, right? So these are different. And algebra mistake, this should be minus. So did it correctly above? Like, let's see. So the second derivative is minus minus. So it should be minus minus. So that's why could not find the second order condition here. First order condition, again, it is not a first order condition but just the derivative. So right, this is the first order condition. This is correct. So maximizer, then if P hat is the maximizer of this, then this is satisfied. Yeah, okay, this is good. This is exactly the right way to say this, right? So first condition, combining these two lines, they are first order condition. This is very good. Let me see. Here, G, notation mismatch. And the first order condition should have some condition. If P hat is the maximizer, then the derivative at P hat should be 0, something like that. Same thing, P suddenly becomes this. So notation mismatch. And also when you say equals to 0, you have to state the condition when this becomes 0. Finally, again, same thing. The derivative equals to 0 is true only when this p equals to something specific value, right? Right? So the sentence is not complete. Okay, and I believe H and I are pretty straightforward, so I'm going to skip that. I believe most of you have done pretty well. Okay, thank you for watching, and again, writing, I know you understand the main ideas, but like understanding and knowing the main idea is different from writing the idea correctly. So that's what I wanted to teach you, and that's why I made these simple questions, pretty simple example. So so yeah, keep that in mind, and when you do the exam, please be more careful, be more rigorous in your writing. Okay, thank you.